Question 5, Part A. Consider the function f of x equals x to the power of 4 minus 4x cubed. Part 1. Show that f dash of x equals 4x squared times x minus 3 in brackets. Given f of x equals x to the power of 4 minus 4x cubed, f dash of x is found by differentiating f of x with respect to x. So f dash of x is equal to 4x cubed minus 12x squared. Now factorising 4x squared from 4x cubed and negative 12x squared, we get f dash of x is equal to 4x squared times x minus 3 in brackets as required. Part 2. Find the coordinates of the stationary points of the curve y equals f of x and determine their nature. Find the x coordinates of any stationary points by solving the equation f dash of x equals 0. In this case, f dash of x is equal to 4x squared times x minus 3 in brackets. So solving 4x squared times x minus 3 in brackets equals 0, given the left-hand side is in factor form, we get the solution x equals 0 or x equals 3. So stationary points exist where x equals 0 or x equals 3. Now the y coordinates that correspond to x equals 0 and x equals 3 can be found by evaluating f of x equals x to the power of 4 minus 4x cubed at these values of x. So when x is equal to 0, f of 0 is equal to 0, and when x is equal to 3, f of 3 is equal to negative 27. So stationary points exist at 0, 0 and 3, negative 27. Next, determine the nature of the stationary points using a table of gradients given f dash of x is equal to 4x squared times x minus 3 in brackets. Now the value of f dash of x is 0 when x equals 0 and x equals 3, since they represent our stationary points. Now I'm going to test around x equals 0 and x equals 3. So the x values I'm going to test are negative 1, 1 and 4. So f dash of negative 1 is negative 16, which is a downward slope. F dash of 1 is negative 8, which is another downward slope. And f dash of 4 is 64, which is an upward slope. So at x equals 0, that stationary point here, this is a horizontal point of inflection. And we can see that because we have a downward slope on the left, horizontal slope, and then another downward slope on the right. And when x is equal to 3, this represents a local minimum stationary point because to the left of this point, it's a downward slope, then it's a horizontal slope, and then it's an upward slope. Therefore, a horizontal point of inflection exists at 0, 0, and a local minimum stationary point exists at 3, negative 27. Part 3. Sketch the graph of the curve y equals f of x, showing the stationary points. Given f of x equals x to the power of 4 minus 4x cubed, we can find the x-intercepts of the graph, in other words, where the graph crosses the x-axis, by expressing f of x in factor form. And we can do that by factorising out x cubed from x to the power of 4 and negative 4x cubed. So f of x can be written as x cubed times x minus 4 in brackets. Solving f of x equals 0, in other words, let y equal 0 to find the x-intercepts, we get x-intercepts at x equals 0 and x equals 4. Recall from part 2 that at x equals 0, we have a horizontal point of inflection. Here is the graph of f of x equals x to the power of 4 minus 4x cubed. Note the expression x to the power of 4 minus 4x cubed is a polynomial expression of degree 4 with a leading coefficient that's positive. So that gives us our characteristic W-looking shape. Here's our horizontal point of inflection at 0, 0. Here's our local minimum stationary point at 3, negative 27. Now it's not drawn to scale, but it's important that we do get the shape right and we get the location of the stationary points that we've found right as well. Part 4. Find the values of x for which the graph of y equals f of x is concave down. The graph of y equals f of x is concave down in the interval where the value of the second derivative is negative. In other words, f double dash of x is less than 0. Given f of x is equal to x to the power of 4 minus 4x cubed, f dash of x is equal to 4x cubed minus 12x squared. That's our first derivative. To get our second derivative, we differentiate f dash of x again with respect to x, so we get f double dash of x is equal to 12x squared minus 24x. So f of x is concave down in the interval where f double dash of x is less than 0. In other words, 12x squared minus 24x is less than 0. Now we can simplify this inequality by dividing all terms by 12, and we get x squared minus 2x is less than 0. Now if we consider the left-hand side, x squared minus 2x, that's a concave up parabola with x-intercepts at x equals 0 and x equals 2. So we're interested in the part of the parabola that's below the x-axis, and that occurs between x equals 0 and x equals 2, not including the endpoints. Therefore, the graph of y equals f of x is concave down in the interval x greater than 0 and less than 2.